Hello everyone and welcome to the class for Geotechnical Engineering. We are studying unit number 1, Introduction and Index Property. So we are learning this first chapter and too many topics we have learned. In the last lecture we have discussed about the three-phase system of the soil and its total phases. Okay, so three-phase system itself is a part of soil mass become from phases like solid, liquid and gases. Okay, and the three stages of the soil is the partially saturated, fully saturated and fully dry condition. Okay, so we have learned in the last video. In this video we will discuss about index properties of soil. So many questions asked on this topic, that index properties of soil. There are too many properties of soil. By that, these properties are very important from the point of view of numericals. Okay, in the next, even in the next syllabus of this subject required these index properties. Okay, so the index properties are the properties exactly related to the soil, or the common properties or engineering properties of this soil. So for this finding out the index properties, we have to conduct some experiment or practical to know the value by this index properties or these properties of the soil classification is been decided. Okay, so the first property of a soil is water content. Okay, so water content, as we know that from the three-phase system diagram, is that water is available, or water is the part of a soil mass. Okay, whatever the soil mass we are considering, the water is the part of this soil mass. The volume of the voids which are available in the soil, which produce a suction force, and when the water came in a contact with the soil mass, this suction or negative pressure or suction pressure just attract the water and fill the void, so that by that way the water is available in the soil mass. The percentage of water which is available in the whole soil mass is known as an water content of soil. Okay, so in many areas, why we require this? Okay, to find out the actual volume of the soil. Okay, so when, or the how much it could be compact, or what is the optimum water content or moisture content to be compact, the maximum density of the soil is the major part when we are just building a dam or a subgrade for the pavement. Okay, or embankment. In that situation, water content plays an important role in the soil compaction and consolidation. The permeability of the soil also depends on the water content. Okay, so water content is the percentage of the water available, or percentage of the moisture which is available in the soil mass. So it is the ratio of weight of the water to the weight of solid. Okay, so when we are talking about the practical view of this water content, we are considering that the weight of water to the weight of solids. Okay, so that's why it is called as moisture content. So water content equal to weight of water to the weight of solid multiplied by 100. This is the formula for finding out the water content. And the water content expressed in the percentage. Okay, so the range of the water content is 0 to 100. Okay, 0 to 100, or we could say in a practical view that any value more than 0. Okay, any value more than 0. So why it is more than 0, any value more than 0? That the if we are considering partially saturated soil, the value will between the 0 to 100. Okay, if we are considering the fully saturated soil, it means that the value, moisture content value is 100%. But if the water, the soil is a submerged soil, okay, saturated and submerged soil, in that condition, the weight of water might be more than the total. If we get the whole soil mass which is under the water, okay, so that the weight of the water might be, okay, might be greater than the weight of solid, so the percentage will go increasing than the 100%. So we could say that the limit of the water content is any value greater than 0. Okay, so I hope you understand this concept, that water content is the important point we required. Okay, so the next property, okay, so next property of from the index property of a soil is void ratio. Okay, so void ratio is important point from the point of view of, again, permeability, capillarity. Okay, then we could say that one thing is that swelling of the soil and contraction and then consolidation, the density. Okay, so the density is depend on the void ratio. Okay, density, what is the density we will study in the next slide. Okay, so density is important when we are using soil as a bearing layer. Okay, when we are considering bearing layer, when there is an embankment, when there is a pavement, when subgrade of the pavement, okay, or a railway or any of the thing, when we are providing subgrade or preparing subgrade, the void ratio is important. Okay, so the void ratio is the ratio of volume of void to the volume of solids. Okay, here volume of void to the volume of solids. So what is mean by volume of voids? It is the volume of space between the solid particles. Okay, in the three phase diagram we have studied that the space between the solids is known as a void, and the volume of that particular void is known as volume of void to the volume of solid. Here it must be understand that when we are considering void ratio represented by small e, the ratio is volume of void to the volume of solid, not volume of soil. Okay, so that, okay, so volume of void can be, okay, so volume of void can be greater than the volume of solids when there is a totally dry soil or which is not compacted or loose soil. If the trench, one trench is excavated, the soil is removed and put at some area, so that that soil is a very loose soil. When you are considering the according to the volume, okay, that the total volume or volume of solid of a per meter cube, we are considering 1 meter cube soil we are taking, which is very loose soil. Okay, so that in that particular 1 meter cube, the solid particles volume of the solid particle also available and volume of voids also available. We are not considering that it is voids are filled with water or air. We are not going in that deep. So the volume of void might be, okay, but we are not showing always that, might be greater than 100%, so that E is considered as a 0 to 100% and greater than 100%. Any value which is greater than 0 is considered as a void ratio, but generally it is between the 0 to 1. Okay, are you understanding this? So this is it. Sorry, it might be maximally considered as a limit of 0 to 100%. Okay, so small e volume of void equal to, sorry, small e void ratio equal to volume of void to the volume of solid. So this value is between 0 to 100. Okay. Next property of a soil is porosity. Okay, so these two properties, that void ratio and porosity, are related to each other and is related to the density. We cannot say as the density, we are connecting that, we are trying to say that it is connected to each other by the volume of void. Okay, these two representing the how much volume of voids available, how much density, how much dense it is the void ratio, or another thing. And another thing is that a void ratio is in the fine particle. Okay, void ratio in the fine particle is more than in the coarse particle. If we are considering that, okay, volume of voids in the we can say that in the soil, clay particle is more than the coarse particle like sand and silt. Okay, not a silt, only sand. So void ratio is expressed in as a decimal, that is in the decimal that it will not multiply by 100. So 0 to 1. Okay, that is 0 0.54, 0 0.36, 0 0.98. This 0 0.36 and 0 0.98 is the value of a loosest and dense condition. Okay. Porosity represented by nu. Okay, actually it is this is the actual notation, but for convenience I represent it by n. Okay, small n. It is the ratio of volume of voids to the total volume of soil. Okay, total volume of soil. So volume of voids to the total volume of soil. So VV divided by capital V. Here you could understand one thing is that even the volume of voids are increased, it does not go beyond the 100%, because the capital V equal to volume of voids plus volume of solid. So whatever the volume of voids, value of a volume of void increases, it will be adding the total volume. Okay, so that the limit for this, that is a porosity, is up to the 100%, or we could say that in the 0 to 1. It might be represented in a percentage or a decimal also. When we are converting, there is a relation we are going to learn in the next part. Okay, that in the void ratio and porosity, that it are interconnect, and what is the actual limit of it. But when we are representing the porosity, we are representing the percentage. Okay, but we are when convert from void ratio to the porosity or porosity to the void ratio, we put that value into the decimals. Okay, so limit of the void ratio is 0 greater than any value than 0, and the restriction for the porosity is 0 to 100%. Okay, 0 to 100%, because whatever the volume of voids available, uh, whatever the voids are there, it will not be greater than total volume of soil. Okay, it will not be greater than total volume of soil. Okay, so this is the property of soil, index property of soil. In the next part, the, the question on the exam to explain the void ratio and porosity has been asked frequently. Okay, and the relation between them and the limit. Okay, and definition will be asked or generally asked in the exam. Okay, so the next part is the degree of saturation, density index. These are the complicated part, and it also related to three-phase diagram, that how the three-phase. I already told you that the three-phase diagram is very important to understand the index property. The degree of the saturation is means that how much the water water occupies the space from the volume of voids. Okay, whatever the volume of void, how much that voids has been filled by water, that percentage or a degree is known as degree of saturation, and that degree of saturation explain the different phases of a soil on the basis of that degree of saturation. And density also, the density also plays the same role, that it represent how much how much mass been contained by a particular unit volume, and that particular properties we will learn in the next video. So keep watching our video. Okay.